So now we're going to look at different trig functions in right triangles. Now we've seen some of these before, and if you recall from Math 2, we saw sine, cosine, and tangent, and we remembered sine, cosine, and tangent by SOHCAHTOA. So remember we said sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. And this opposite, adjacent, hypotenuse is in reference to a right triangle and the sides in relation to each angle. So we have sine, which is opposite over hypotenuse, cosine, and tangent, and we are going to add 3 more, which are kind of like the opposites. So like the opposite of sine would be hypotenuse over opposite, and we call that cosecant. The opposite of cosine would be hypotenuse over adjacent, and we call that secant. And then the opposite of tangent would be adjacent over opposite, which we call cotangent. Right? So we have 3 more that we've got to remember. But really, as long as you can remember which one is, goes with which, the opposites. So all of them have to have a co. So sine goes with cosecant. Cosine is already a co, so it goes with secant. And then tangent goes with cotangent. Right? So remember, all of them have to have a co, and then you just flip it. So for example, if I have this special right triangle down here that is 3, 4, 5, I'm looking at theta, which is this bottom right angle here. So sine, opposite of the theta, is 4 over hypotenuse 5. And then that would make cosecant 5 over 4. Just flip it. Cosine, adjacent 3 over hypotenuse 5, would make secant 5 over 3. And then tangent, opposite over adjacent, would be 4 over 3, which makes cotangent 3 over 4. So for an example, we've got, I want to find the 6 trigonometric functions for angle G. So angle G is down here. So in relation to angle G, this 24 is our opposite, 32 is adjacent, and then the hypotenuse is always across from the right angle. So to start with sine, sine of G is opposite, so 24 over hypotenuse 40, which we need to simplify our ratio. So 24 and 40, 4 goes into both, right? 8 goes into both, actually the bigger number, so that gives us 3 over 5. All right? Cosine of G is adjacent over hypotenuse, so we have 32 over 40, and 8 goes into both of those, so that becomes 4 over 5. And then tangent of G is opposite 24 over adjacent 32. And again, 8 goes into both of those, and that gives us 3/4. Right? Once you have the 3 that we've already seen, to find the other 3, we just flip them. So the opposite of sine is cosecant, right? Remember, they all need a co. So the cosecant of G would end up being 5 over 3. Right? The secant of G would be 5 over 4. And the cotangent of G would be 4 over 3. Okay? It's just the opposite. They all go with 1. Everything has to have a co. All right, so for angle A this time, which is down here, the 20 is opposite, the 15 is adjacent, 25 is hypotenuse. All right, so then my sine of A is opposite 20 over hypotenuse 25. 5 goes into both of them, so that becomes 4 over 5. Cosine of A, adjacent over hypotenuse, so adjacent is 15, hypotenuse is 25. 5 goes into both, so that's 3 over 5. And then tangent of A, opposite 20 over adjacent 15. 5 goes into both, so that becomes 4 over 3. Right, to go along with sine, we have cosecant. Cosecant of A, we just flip it, 5 over 4. Then to go along with cosine, we have secant. We flip it, 5 over 3. And then to go along with tangent, we have cotangent. Flip it, 3 over 4. All right, some other types of problems that we'll see is that we have a right triangle, and we've got that's supposed to be angle. I don't know what happened to the symbol there. Angle A is acute, and then tan of A is 5 over 3, and I want to find the value of cosecant of A. Okay, so just to remember, we have sine that goes with cosecant, cosine goes with secant, and then tangent goes with cotangent. And we'll come back to that in a second. First, I'm going to draw my triangle. Every time I'm given this information, I'm going to draw a triangle, and I'm going to label this angle up here A. Right, so if tangent of A is 5 over 3, that means it's opposite over adjacent. So the opposite side of A is 5, and the adjacent side is 3. Now I'm going to use that information to find cosecant. Well, cosecant goes along with sine. Sine is opposite over hypotenuse. So that means my cosecant is hypotenuse over opposite. So that means it's going to be something over 5, but I've got to find my hypotenuse. Well, I know 2 of 3 sides of a right triangle, so to find the missing side, I use the Pythagorean theorem. So 3 squared plus 5 squared equals whatever my hypotenuse is squared. So then we have 9 plus 25, and then 9 plus 25 is 34. So to get the hypotenuse, we square root it. So my hypotenuse is the square root of 34, which nothing goes into 34 except for 2 and 17, so we can't simplify it. And then to just rewrite my answer, so my cosecant of angle A is going to be the hypotenuse, square root of 34, over the opposite side, which is 5. Okay, again, make sure 1, we simplify our radicals, and 2, we don't leave a radical in the bottom. You have to rationalize if there ends up being a radical in the bottom. Another example like this is I have sine of B is 2 over 3, and I want to find cosine. So again, draw my triangle, pick my angle to be B, and sine is opposite over hypotenuse. So opposite of B is 2, hypotenuse is 3. Cosine is adjacent over hypotenuse, so I need to find my adjacent side. I'm going to use the Pythagorean theorem. X squared plus 2 squared equals 3 squared. X squared plus 4 equals 9. Subtract 4. X squared equals 5. And then square root it. So then my adjacent side over here is 5, or root 5. So then cosine of B is going to be adjacent, root 5, over hypotenuse, 3. Again, make sure that there's a simplified radical and no radicals on the bottom, in which we are good in both cases.